S equals C+, and M equals S, the designations for Optibelt belts, which can be used in the set without further measurements. Easy to fit, simply reliable.
Hello and a very warm welcome to Master Your Drive, the video series from Optibelt. I'm Sophia, and today Patrick will explain the terms S equals C+ and M equals S to us.
Yes, hello Sophia, thank you very much for the invitation. I'm happy to be back here again. As you already said, we have two equations, M equals S and S equals C+. These are for our length tolerances, so that the belts can be used in sets without being measured. I've also brought an example for us, so I'd like to ask you to just tension the belts.
Sure.
So, as we can see, one belt is already quite tight, while the second belt is still relatively loose in the V-belt pulleys.
But why is that? The belts are identical, aren't they?
Correct, the belts are the same in terms of length, type, and also the product family. But since they're now running in a set, some special rules apply, and those are the so-called set tolerances. And we're going to take a closer look at that right now. So in order for each belt in the set to carry its share of the load equally and reliably, the individual belts need very tight length tolerances relative to each other. Let's just look at an example of a wrapped V-belt SPB profile with a length of 3000 millimeters. So, according to this DIN 7753 or ISO 4184, the length tolerance for the individual belt is plus or minus 1%, which is plus or minus 30 millimeters. The set tolerance, however, is only 4 millimeters. Because of this, the first possible set of individual belts starts at a belt length of 2970 millimeters and ends just 4 millimeters later at 2974. The next possible set would then be from a length combination of 2971 to 2975 millimeters. And the following set, as before, from the length 2972 to 2976, and so on and so forth. Yes, and that continues until the end of the entire length tolerance range. So thanks to our special manufacturing technique, the Optibelt rotary vulcanization process, or ORV for short, we're able to manufacture the belts precisely to the nominal size within the smallest length tolerances and then subsequently stabilize them at this length. That's what we call our S equals C+. Set constant plus manufactured to nominal size. So Sophia, I've brought us another suitable set of belts in the S equals C+ set tolerance range. I'd like to ask you to tension the test model again.
That definitely looks better.
Yes, exactly, because now the set tolerances match as well. For the other example, for M equals S tolerances for the raw edge belts, of course, I've also brought an example for you, and that's what we'll look at next. Let's take a belt with 3000 millimeters as an example again, but this time with a raw edge XPB profile. The standard remains the same, so the length tolerance also remains the same, plus or minus 1%. What's new, however, is that the set tolerance for raw edge belts is a bit different, and that is now 6 millimeters. As we've just seen, this results in the first possible set within a tolerance range of 2970 to 2976 millimeters. The second possible set will then be at 2971 to 2977 millimeters, and it continues like that, as we already know. Due to this different manufacturing process for raw edge V-belts, we are now more closely tied to the shaping tools. This means that the actual belt length is now within the overall length tolerance. The produced belts themselves then remain fixed to their length tolerance. That means we fix the belt length and the tool for it. We call these properties M equals S, or in the long form, match sets. Yes, for this I have once again brought you a suitable set of belts in the M equals S set tolerances. Please tension the drive again. There. Yes, that looks much better already. That's all from my side for S equals C+ and M equals S.
Great. Thanks, Patrick, for the great explanation. You can find all this information and further documents on the website www.optibelt.com. Thanks for watching, and see you next time at Master Your Drive, the video series from Optibelt.